Hello everyone, welcome. So today for the speaker is Santosh Borse. So he's a senior engineer at IBM Research, and in today's talk we'll be learning how to prepare the dataset for LLM training using database. Yes, the next course you'll hear is from Santosh.
Thank you so much. How is everyone doing? Hello, my name is Santosh Borse. As introduced, I work at IBM Research. Our team is responsible for preparing data for IBM's own large language model. Recently, we released IBM's Granite 3.0, which is currently at the top of the leaderboard in 3 billion parameter size of the models. It is at the base model as well as the instruction model. Today I'm going to talk about the data challenges we faced when we prepared data for our own large language model, and the tool we designed to overcome those challenges. And recently we open sourced that tool, and I wanted to introduce that tool to you. Is my voice audible? You can hear me? Because
this is like, I cannot speak like this.
So this is you might have known that from 2018, since the BERT model launched, there is a surge of these large language models. These large language models are ever consuming, ever hungry for the data. You can see that this GPT 4.0, which uses the 5 trillion tokens, and it says that by 2025 we will be run out of actual internet data. And then there is a quest for generating more synthetic data for it. So what we are talking about is ingesting whole internet into these models. And you know the problem with internet, that most of the data from internet is not good. It has a lot of duplicates, it has a lot of issues. And at IBM Research, when we started this project of building our own data preparation pipeline, we solved those problems using the tools we created, and recently we have open sourced those tools. So you might have heard this data is the new oil, right? And there are many variations of this phrase, that data is new oil. It signifies the value of data. It means that in this century, data will be as valuable as oil. But if you think of it in other way, it also draws the similarities between the oil and data. That oil in its crude form is not very useful. It needs to be refined, it needs to be extracted, it needs to be cleaned, it needs to be distributed to get value out of it. And same is true for data, where just having a raw data will not be very useful. And we might have seen that in, I think, 2017, Microsoft started its own chatbot, and within few minutes it started saying things which it should not say. And that's the reason, that because the data, looking at the data and curating that is a huge challenge. Like we had that challenge in last century about cleaning the oil. And as internet is a huge source of data. For example, there is a company or an organization called Common Crawl. They crawl the internet from 2007. So if you go on their site, you will see there are snapshots created, which is from X time to Y time, and that snapshot contains the whole internet crawl from that period. And it's a petabytes of data. It's hosted on multiple cloud storages, and it has like 250 billion. Recently, they released the snapshot from October 3rd to October 16th, and you can see it has 2.5 billion pages, and it's like 350 terabytes of data. So every new snapshot is increasing. It's like huge data we are generating, right? Because now more data is being generated by these large language models also. So it's like snake biting its own tail, where it's a circle forming. There are many other data sets available. Some are paid, some are free, and those are also massive in size. Where, for example, refined web is from Hugging Face, where they did various processing on data, and that's supposed to be a clean version of data, their version of clean data. And same Wikipedia considered to be a very high quality data, whereas data coming from internet is considered to be a low quality because there is no, it's a public data, so it can have anything. Along with the quality of the data, the format of data is also a huge issue because every HTML page is designed differently. It has a lot of boilerplate code. So sniffing the right content which you want for your model is very important. And not just pre-training. Pre-training is something which bigger companies do. It's not something usually individuals or small companies do because it's very expensive process. But even for fine tuning, you need to have access to clean data. Clean data is very subjective term as well because there's no way you can look at the data unless you read the data. There's no way to know it's clean or not. For example, Hugging Face not only hosts the data set models, but it also hosts the data sets. So there are various data sets available which you can use. But these companies which is building large language models, they need access to all the data. There's only one place that, for that data is internet. I heard somebody saying that in next 20, 30 years, when we look back, we will say that internet, one of the most important job of internet was to provide data for large language model. And we'll see whether it did its job well or not when we reach there. So data quality is a huge issue. It's we need to, it's not just the, because quality is a subjective term, so it's not just like you want Wikipedia data, because Wikipedia is like maybe 0.1% of overall data. So you need to have a data which is a variety. It should represent the use case which your model is going to perform. So let's say if your model is meant to interact with a college student, then you cannot have 17th century English data with it. You need to have a latest data so that it can understand the linguistic patterns of today's day. Overfitting versus underfitting. If you have data which is of same category, then your model automatically overfits for that category. And same way, because it's overfit for one category, it is underfit for another category. Bias, you know that bias is a big problem on internet where everybody express their opinion whatever they want, and now how do we know whether that data we want to have it on? There's a lot of personal information, so you don't want your model to leak somebody else's personal information. It may be fine for some open source model which nobody has control, but for companies like IBM, Microsoft, which provides the model to enterprise customers, it is very important that it should not say things or it should not leak things which it should not. It should not have copyright data as well, otherwise somebody will sue these companies. There's a huge bad data on internet. There's a lot of data abuse, profanity. We don't want our model to learn those things. And the problem with the bad data is not just that the end result of the model is bad, but it also means that the time and cost required for training increases. These trainings are very expensive. There's millions of dollars required for these trainings to happen, and anything which makes the model learn bad thing not only makes the quality of the model bad, but it also increases the time required for the training. Nowadays there are new methods coming which is trying to unlearn the model, but that's like a superficial outside of the pre-training process where go and try to specifically ask model to unlearn something by overwriting those particular activated areas of the model. So these are the examples, duplicates. For example, bad data has a lot of duplicates, whereas good data needs to be unique and distinct. There are a lot of typos and spelling errors because these model doesn't inherently understand anything. They are just the next tokens prediction models. They just understand what is going to be my next token. So it's like a stochastic parrot where it is trying to say the word without actually understanding what it is saying. And that's why it's very important to have consistent data, because all inconsistency will eventually come out in the output of the model. Hallucination is a huge problem, and that's why you need to have very factual information. Otherwise, the model will definitely come out toxic. People who want to play with the model will first try to do this is to try to bring out something bad out of it, right? That's like a regular thing, and you need to have information which is not being toxic. It also goes back to a point where there was a famous paper from Microsoft Research. It's called "Textbook is All You Need," and that paper describes that how they trained a model called PHI-1 that was much smaller than the bigger model. So it was like 1.5 billion parameter model, and it was able to do as good as 34 billion parameter in many tasks, and by just using the textbook as an input source. Obviously, they selected the areas which they wanted to demonstrate, but that demonstrated the importance of having good data for your model. And again, it's not just pre-training, which you definitely need a lot of massive data preparation, but it is also for the fine-tuning. So this is what it looks like. For example, deduplication, you remove. Usually these are the very standard filters used, where it says you want to deduplicate your data, where if there are duplicates, you try to remove those duplicates. There may be a sentence level where there's a one document, let's say a one HTML page, where you have those duplicates, or it may be across the pages. For example, a viral news may be appearing at multiple places, and you don't want to ingest that viral news in your model, because then model becomes have information overload related to those particular news. There are different type of deduplication. So usually when the news appears on multiple sites, there are some words split across just to make sure that they are not exactly the same. And that's called a fuzzy deduplication, and we will see what fuzzy deduplication is. There are quality filters. For example, if the content is a mixed language, then it may not be useful for certain categories, because most of the model in the smaller size are usually based on specific language, usually English language, and having this mix will mean that it will also learn that and consider it as English and then try to learn it. There are content filters, for example. There may be some bad words appearing in the context. So do you want to remove that document, or you want to replace those words with some milder versions, so that you keep that thing and then make your model more smarter. Again, there are a lot of leaks happening on the internet, so privacy reduction is very important. There are rule-based cleaning where you say, okay, if I have a document with more than 100 new line characters, then maybe it's not useful. Because again, these rules needs to be covered with. You cannot verify the accuracy of these rules on the larger basis. The only way to know is to actually read that data, which is impossible. So many of these companies, what they do is they take a snapshot or a subset of data, run a filtering on it, and then train a small ablation model. So we call it ablation studies, which is like experiments you have performed, and with various filtering criteria. So there's, let's say if you have 10 filtering criteria, then you have a different numbers for every ablation study, and then you try to find out which criteria yields the best result for you, and then you try to replicate that on the larger model. So at IBM we did more than like 150 ablation studies to come up with the right mix for our filtering. So you can also imagine this as like a huge cockpit where you don't know which button is going to do what. So to learn that, one way is to try to change one button and then see what's the effect of it. Any question?
For the content filter, seems to be the adjectives like stupid and idiot, fairly mild. There is a bias, presumed bias.
Right.
What if it appears in a novel, or what if there is a recording that somebody actually said?
Yeah, and that's a huge problem, because not bad words can be used for teaching somebody that these are the bad words, right? I mean, if you say, okay, if somebody is teaching you, okay, what are the 5 bad words? So I'm going to never use those 5 bad words. So let's say I'm teaching 6th graders that, okay, these 5 words you shouldn't be using. Now it's a legitimate data, right? Now, and that's where the balancing act comes, where you want to be really strict about it, or you want to really take it into a context. And there are techniques for it called as LLM as judge, where instead of you using rule-based filtering, where it says, okay, anything which has stupid is removed, instead of that you take those samples which has those bad words, and then you have another model which is trained to understand which bad words are okay to have, which sentences with the bad words are okay to have, and which sentence should not be there. And that model will tell you, give you a score about HAP score. So IBM recently also released HAP model, which is used by NASA. And that has the ability that you give a text or sentences to it, and it gives you a HAP score. Where it says lower means it is milder, whereas higher means there's a high chance of HAP.
I'm glad my question wasn't stupid. Can I ask one more?
Sure.
So quality filters, now there are LLMs that are multilingual.
Yes.
Now here, as I see it, it's like language. So if there are 2 languages or 2 alphabets, it's going to clean up one.
Right.
Is that always, I'm asking more basic question that if I have data, can it be in 2 languages or 2 alphabets, or LLMs don't operate?
Right. So usually, if one document is mixed, because how the way these model learns is there's no supervision, right? So it's like what you're saying is next token is the learning data. So let's say this document contains important information will be an input, and the next token, whatever that token is, will be output, and that will be a training data. So you don't want your training data to learn that you want to mix the languages. But there are data sets, for example, translation data sets, where you want to translate from one language to other. That contains such kind of data.
You mentioned the model. You mentioned the model that was used to distinguish, this like model-based content filter.
Right.
It seems like you run into the same problem to train that type of model.
Yes.
So
right.
Again, then comment on that. And at a certain point, how do you reconcile that? Do you need human intervention?
Right, and that's where this AI race is, right? To build the model which So all these companies are actually working on this. So this is the real problem they are facing is what is the right data to know that my model is good. And any data, it could be this if you have a model to detect hate abuse, profanity, what is the right level? Let's say, again, it's going to give you a score. Right? 1 means it has matched everything, 0 means it hasn't matched. But usually the score is probability between 0 and 1. And now it's also dependent on us to consider. And that's why the ablation studies comes in, where you have some human annotated data, or there are very high quality data sets available, or considered to be high quality, then you use that for the. Again, these models, when we say, okay, open AI model is the best in class, the reason is because it was tested on certain benchmark, which is known. So if you come up with a model which is good on those benchmarks, that model will go on top of the leader. But that doesn't mean it's actually good, because it could be only good for those benchmarks. Do you have any questions? Sorry. Right. So IBM Granite is another open source model like Facebook Meta's Llama. It is a transformer-based architecture where the model weights are openly available, so anybody can take a Granite model and start using it. They don't have to buy or anything. It's same as other open source category of the model. And this is the data journey for our first version of the IBM Granite model, where it actually went through these rough processes of preparing data for it. So we have a IBM data file, which is you can think of it as a large database of all unstructured data, which contains data from internet, which is in the form of common graph, and then there are certain data sets which is available on Hugging Face. Some of those we crawled ourselves. Some of those we purchased as well, and that is used for the exact deduplication. The exact deduplication looks for a content which is exactly same, whereas fuzzy dedupe is where there is a variability in the content, but more or less their gist is same. Then it goes through a language identification to understand what kind of languages it is, because if the English is a model of the language of the model, then you don't want to mix other languages. Then we split the data into sentences to understand whether there is a hate abuse and profanity. When it goes to beyond certain threshold, we discard that document. There are document quality annotations. For example, some are heuristic based, means if there are a lot of blank spaces, then that document quality is bad. If there are some words repeating all the time, then it's bad. If there are low ellipses in it, it is bad. And number of characters, if it is too large, then it could be something wrong with it, or if it is too small, it could be something wrong with it. So there are all heuristic. Again, we have to play with these heuristic, because we may end up doing too much filtering, and too much filtering again shows may create a bad quality, or not that it may not reach to a right potential of the model, because we end up filtering a lot of content which we should have kept. There are certain sites which we know that have very not good data, like porn sites. We know data coming from those sites, or if URL contains some bad word, then we definitely remove that URL, irrespective of what the content is. And then the last step is to do a tokenization, where all these collected and filtered data is tokenized. And while doing these processing, we obviously developed our own tools and framework, and that framework we thought could be useful for the outside world also, because family of models are all open source, so we wanted to see what we can give more to the community back, and these tools is our payback to community, where all these things we open source as a data prep kit, which I'm going to walk you through. So this is a data journey. So we started with the text extraction, which is 28.7 terabytes of data, and just removing duplicates slashed it to 13.8. So more than 50% of reduction itself in just duplicates. So you can think of extent of duplicates in this data, and that to a curated data. So there may be, if you use regular internet data, you will find real duplicates there. After removing HAP, block listing, and document quality filtering, we left with around 8 terabytes of data. So you can see almost 75% of data is gone before we even use for the tokenization.
Quick question.
Sure.
Duplication.
Mm-hmm.
Does it consider gravity or like the order of the words, or is it that string?
Good question. So, I mean, regular duplication just calculates the hash and matches the hash. But there's a fuzzy deduplication which uses the min hash technique, where it says instead of calculating the hash on the full text, it picks up the part of the text and try to calculate a min hash, and then try to put it in a two-dimensional space and see what is the distance between those two contents. If it is, then it gives you a score, that this is the score of how close two documents are, and then we make a decision whether we want to keep those or if we want to get rid of those.
So depending on the size of the data that you're trying to figure out if it's duplicate, there will be an overhead, right? So is there a technique to have some optimal way of deduplicating?
Yes, so I mean, one way is to actually do a string comparison, right? Where you take two strings and you do strcmp, or string equals if you are using Java, but that will be inefficient. So instead of that, we use for deduplication, there is hash calculation. You calculate the hash, you can calculate MD5 token, and then from there you can see. Fuzzy deduplicate, there are algorithms available which actually does the calculates the Jacquard similarity. So Jacquard similarity is one of the similarity algorithm where if you have two sets, how these two sets are similar and how close they are. That's the algorithm used, and then that's the algorithm it uses behind this. And all these things takes huge amount of compute resources, because you want to, if you have 1 million documents, you almost have to do a 1 million comparison, and then the cache has to move across these 1 million comparisons. And that's why this data prep kit is one of the reason is scale, because everything works for the smaller data. So if you have like couple of documents, couple of 100 documents, you can write your own data cleansing or your own logic, and it will work, but it won't work for millions of documents or billions of documents. And that's what the one of the engineering problem is to process them in a timely manner, also in a scalable manner. And that's why this data prep kit uses 3 or 4 modes of parallelization, where we have a pure Python way where you can run these transforms. So all these things all the operations you perform on the data are called transforms. So if you start with the left side and consider this as a tool or framework, then you can just Parquet. Parquet is a very popular nowadays columnar data distribution format. It's like considered as a table. We can ingest PDF, we can ingest HTML, we can ingest GitHub repositories. in data prep kit we support two modalities. One is language, where you can take the regular HTML pages, and another is a code, where you can ingest the code data for training the code models. And code data is usually GitHub repository. You go to GitHub repository and say download it as a zip file, and the zip file contains all the code in it. Then we convert all these modalities, all these different formats into Parquet, which is our format to use for the regular. And then we have these inbuilt, transforms. So PDF to Parquet converts PDF file to Parquet. There is a HTML to Parquet. And then there are actual processing, where we say fuzzy dedupe, malware detection, whether we say the code contains a malware, header cleansers, so if there is a HTML, then there is how do we clean that HTML, boilerplate code. There's a document chunking. There are a lot of filters or transform switches. So there are two types of transforms we have. One is where we add more column to the data, where it says, okay, whether it has HAP, and we add it as code in the column. It's like augmenting without actually deleting. And there are filter types of transforms which actually removes the data. And then you can stitch together all these based on your own requirements. We call it data pipeline, where you stitch in such a way that the output of first one becomes the input of next one. So it's like a pipeline where data flows to various processes, and a different thing happens at the different places. And all this is built on three scaling mechanisms. So one is Python, so you can run these on your local laptop. And then you can also run it on your Ray cluster. So Ray is another way of scaling running your workload in a more cloud or distributed fashion, where Ray spawns its own workers, and then you can say that, oh, I want 100 workers, and then there will be 100 processes running in parallel to process that data. So based on the size of your input data, you can make use of Ray or Spark to parallelize the process. Again, that is abstracted from the developer. So if you are using this, you don't need to understand Ray or Spark. You can just write a pure Python implementation, and the framework will take care of making it run on Ray or Spark. Again, along with these existing transforms, you can also bring your own transform. So for example, it's something specific to your format of the data, or specific to your data, or if something which is there but it doesn't actually meets your requirement, then you can extend the existing transform, or you can write your own transform. We call it bring your own transform. And the data prep kit can be used for any of these use cases, where you can use it for pre-training, which we don't do very often. But there are fine-tuning, instruction tuning, and there are applications where you want to prepare your data, put it into a vector database, so that LLM can use it along with your query to become more smarter, or to look for a factual content. Yes. So these are the features it has. It's open source. It is used for building Granite model. It's already tried and tested for data center scale operations. It supports bring your own transforms. I have these comparing these data tools. So there are other available tools as well, but DPK stands on its own because it is meant for application developer as well, and you can extend the existing functionality, which other tools doesn't support that well. And if you are an open source contributor, or if you are looking for a open source contribution to increase your contribution, then data prep kit is could be one of the candidates you can consider. We're looking for contributors, so we're looking for people who can fix bugs, report new issues, improve our transforms, improve our documentation. There are some sample notebooks we have. You can try using those. I have here some tutorials. So, for example, this one, which you can run it on Google Colab, so you can just use this link or this barcode to get to this Google Colab, and you can just run it. You don't need anything. You don't need to install anything. It has the setup steps. You just follow and try to get a flavor of how data processing is done. So this is a use case for preparing data for RAG, and this is one for preparing data for fine tuning, where we can take the code data and fine tuning. Again, it has a little different thing because it is meant for the code data. And again, I think this is a good project if you are starting on open source or if you want to contribute, because this is really recent and as well as very active project. Have any questions? I think we have 4 minutes left, so.
We have a benchmarking these data sets, the quality or something. Is there some type of metric that we
Right, so on Hugging Face there is a leaderboard of data sets also. You can put data set on its own is, I mean, it depends on how. Usually data has a model card with it. They call it data card, and that data card explains how that data was gathered, what is the processing there, and based on that you can decide on how, I mean, whether that data is useful for you or not.
Is it able to detect the data structures in the documents, such as like headings and lists and all of that?
From extracting code from the document, is that?
The structure of the document. So like a PDF, if it has
Right, yeah, it
headings,
does.
lists.
Yeah, so it has this, for example, this PDF to Parquet, that's actually able to detect the paragraphs from the PDF file and able to extract those paragraphs.
And that primarily uses document.
Docklink, yes. Use Docklink for that. You can use Docklink, but with this you get the benefit of using Ray, which is then, if you have a lot of PDF, let's say thousands of PDF documents, then you don't have to process them serially. You can do it in parallel also.
I mentioned some companies do pre-training. I've not come across it.
So pre-training is the first training which happens on the model. So it's one of the, it's usually a huge, you consume huge data because that's like a foundation knowledge of the model, and it's usually lasts for days or months, and it could be millions of dollars. So I think this, and there is a very nice paper from Llama called Llama Hertz, and from IBM Granite 3.0, which actually tells you the cost and the environment cost of the model pre-training, and it's quite significantly large.
Is Granite kind of a generic term because I've seen it at the
Yeah, so it's a family of model, because there are various versions of model. We have a code model, we have an instruct-tune model, we have 3 billion model, 7 billion model, 13 billion model. So different size of the parameters. That's why it's not one model, it's a family. Like Llama is also like that. Llama is not name of a specific model. It's the family of. Any more questions? Thank you.
Thank you.